Welcome students. Today we will discuss how to solve max-sin problem using hill climbing algorithm. Okay, the objective function for max-sin algorithm is given as sine of pi x dash by 2 power d, where x dash is the integer form of x vector. Okay, let us see. So as usual, we already discussed the syntax for hill climbing algorithm, and the first argument is initial solution, fn is objective function, and change is change function, delta function, lower vector and upper vector, and this is control list parameters, and then final argument is min or max. So import the liquid file and then define the max-sin function. This is our max-sin function, max-sin function, and then define the d is equal to 8 dimension, and then initialize the solutions. So here initialize the solution, okay, and then define the control parameters, so which is defined as a list, and then define the maximum number of iterations, and you have to report it and implement the iChange function. Actually this is same as our previous video. So where we take the old value PAR and we will compute the new PAR one. That means if you give old solution, you will get new solution. Okay, so we have to define that new solution, it should be between the lower range and upper range. Okay, so here for implementing the step function, we are using the normal distribution function with mean 0 and 1. So in our application, you can see our question paper. You can see x is a binary vector. Actually, if you give binary vector, it will be converted into x dash integer form. So therefore you have to implement this statement. Okay, so that means you will get some value in the form of fractions, okay, floating values. It will be converted or it will be rounded off, because we want only the binary values. So we have to perform the rounding function, and then after that we have to add to the old solution to get new solution. And again with this statement you are checking whether it is in between lower and upper. Actually what we are doing is we are clipping. If the new value PAR1 is less than lower, means you have to return lower. If PAR1 is greater than upper, means you have to return upper. If nothing condition fails, means you have to return the as it is value. So once we define this function, now it is time to call the hill climbing algorithm, and then you have to pass the initial solution, max-sin solution, pass the max-sin solution. This is the objective function, max-sin. Okay, this we have already implemented, and then define the iChange function. Here in this, if you want another random function with different uniform distribution also, you can modify it. If you want Poisson distribution, you can modify it. So then define the lower vector, upper vector. We want to find only between 0 to 1. Finally pass the control arguments, and we want to type max. So let us see how it can be executed. So now you can see this at 1,000, 1,000. Here the dimension is 8. We got this value. Okay, this is the value we got. This is the maximum value we got. Similarly, if you want a min, you can change this, and again you can run. So this is the minimum value you got. Okay students, you can refer the statement one by one. So what we have done, a simple thing, we have defined the objective function, we have defined the change function with the help of the normal distribution, and then we are clipping the lower values and very lower values and very higher values, and then we are passing it to the hill climbing function to describe the output. So in the control list we are passing for how many iterations we have to pass. If you want 100 iterations, that also you can do. So whatever the iterations, the min value is, so that is a problem with hill climbing. So once it got stuck to the local minima or local maxima, it gets stuck. Okay. Thank you, students.